Hidden deep within the pages of the A-Math TYS lies a set of questions so unforgiving, so difficult, that it traumatized many batches of students taking the O-levels every year. As your favorite detective axolotl, I took a deep dive into the TYS and compiled what I think are the most brutal and challenging questions into one video. Welcome to the TYS Gauntlet. This question from 2023 is a classic question of someone like LeBron James throwing a basketball vertically up into the air until it drops and hits the ground. In this question, the h value is the height above the ground and the time elapsed is t. So, to solve for the first part, the initial height is basically when t is equals to 0, so let's sub that into the equation and we get h is equals to 1.75, which is the initial height of the ball. Next, we just complete the square by factorizing out the negative 5 from the t square and the t term, and then we just use the method that we did like a billion times by now, and we can get negative 5 t minus half square plus 3. Before we calculate the maximum point, let's try to sketch out the quadratic graph where it starts at 1.75 meters, goes up to the maximum point, and then hits the floor. Then, because the maximum point is negative hk, then we can get the maximum point of t is equals to 0.5 and h is equals to 3. Now the next part is quite tricky since they ask you to explain why this point is not just half times 2. Now because the ball starts off at an initial height of 1.75 meters, you can see that this portion over here and this portion over here are not symmetrical, so therefore you can't just take this value and multiply it by 2. Now for the last part, to find the time taken when the ball is above 2 meters, let's draw the line h equals to 2 on the graph, and you can see that it refers to this region over here. Now we just take the equation of the curve and we equate it to 2 to find these two intersection points here, which gives us the value of t is equals to 0.0528 and t is equals to 0.947 seconds. Then the time above the height of 2 meters is this region here, which is just 0.947 minus 0.0528, which gives us the final answer, 0.894 seconds. This question looks quite confusing since they're asking for what conditions must apply to A and C. Now firstly, since it's always negative, we know that it kinda looks like this, so it has to be a sad face where it doesn't touch the x-axis. Then we know that the first condition is A is less than 0 since it's the coefficient of the x squared term. Also, because it doesn't touch the x-axis, there are no real solutions. So we know that b squared minus 4ac is less than 0, so substituting in the values, we can solve the inequality and we can get the second condition of ac is greater than 9. Okay, I had to add this in because I totally forgot that this part of the chapter even existed, because it's actually inside the syllabus document right here, even though it's never come up before in the TYS. So, to factorize a cubed plus or minus b cubed, you kinda have to memorize these formulas over here, and I don't really have a quick way, but this is how you should do it, I guess. To factorize this equation, the first step is to make it into the a cubed minus b cubed form, so we kinda have to cube root 8 and 27, and we can see that a is equals to 2x and b is equals to 3y. Now, because it's in the a cubed minus b cubed form, we can finally factorize it and we can get the final answer of 2x minus 3y times 4x squared minus 6xy plus 9y squared. This question is from 2020 and you will see this year appearing a lot later on in the video. This question is really interesting because they first ask you to consider the general term, and putting all the values in, it kind of gives us these three terms over here first. So to prove that every term is dependent on x, it's kind of saying that the x to the power of 0 term doesn't exist. So let's try to find the r value that gives us this x to the power of 0 term. Now if we just focus on the powers of x and we equate it to 0, we can solve for the r value, which gives us r is equals to 16 over 3. Since r is not a positive integer, we know that this independent term doesn't exist. Now the next part actually requires the idea from part A that since there's no independent term in this binomial expansion, nothing can multiply with this 5 to give an independent term of x. Now we just have to care about multiplying with this negative 2x to get an independent term, where we need x to the power of minus 1 from this binomial over here to sort of cancel out the x. So let's equate the general term to negative 1, and then we can get r is equals to 5. So now let's find the coefficient of the x to the power of minus 1 term in the binomial by subbing r is equals to 5, and we only care about the numbers, which gives us 1512. So finally, the independent term is just 1512 times negative 2, which gives us the final answer of negative 3024. I actually love this question over here because it's really creative. And the first part is pretty easy because to show that 2x plus 1 is a factor, we try to sub in x is equals to negative half into the polynomial and it works out to be 0. Since we know that 2x plus 1 is a factor, we factorize this polynomial here by doing long division, and we can get 2x plus 1 times 3x squared minus 5x plus 2, which we can further factorize this quadratic over here, and we get our final answer. Now for the next part, looking at all these terms over here, we know we gotta convert them into 2 to the power of y's. So this 4 to the power of y will become 2 to the power of y squared, and then this 2 times 2 to the power of negative y will become 2 over 2y. The next step is to multiply by 2 to the power of y to every single term, and we can get something like this. Now, we let u is equal to the 2 to the power of y to make the equation easier for us to solve, and then we can get 6u cubed minus 7u squared minus u plus 2 is equal to 0. Now, do you notice something really familiar about this polynomial over here? That's right, this is the exact equation that we have in part A. So we can just take the factorization that we did in part A and apply it here, and we get u is equals to negative half, u is equals to 2/3, and u is equals to 1. Because u is equals to 2 to the power of y, we can try to solve for y by taking a LG on both sides, and we have to reject this negative half solution here because we can't log a negative number. For this one, we bring the y down, and we can solve for the value of y to be negative 0.585, and for the last one, y is equals to 0, since anything to the power of 0 gives us 1. For the last part, since they want us to express the answer here in the log form, let's try to take log base 2 on both sides, and you can see that this becomes log base 2 of 2, which gives us 1. Now for this log 2 over 3, since it's a fraction, we can rewrite it as log 2 minus log 2 3. Now since log 2 is just 1 as we established before, we can get our final answer in this form, and we are done. This kind of logarithm word problem was something I wanted to cover in the Sec 3 video, but I didn't have the time to. So, in order to find this constant k over here, the first step is to find our initial conditions. So when t is equals to 0, the value of p is 100. Now since it said that when t is equals to 5730, the value of p is half, so it becomes 50, and we can write out this equation over here. Now dividing both sides by 50 and taking ln on both sides to kinda get rid of the e, we can get the final value of k to be 0.000121. Now that we found the value of k, we can put it inside our general equation over here, and the next part becomes really simple. Since we want to find the percentage of carbon when t is equals to 8000, we can just sub this value in, and we can get the final answer of p to be 38.0%. Okay, this part here is pretty tough because this time you can't find the value of the constant c because not enough values are given to sub it in. So let's look at the initial earthquake with size s is equals to 2.4 first, and we'll put that in the equation, and we call this equation 1. Now since we want to find the size of the new earthquake with 50 times the intensity, I becomes 50i, and we call this equation 2, where we want to find this value of s over here. The goal now is to try to solve these two simultaneous equations. So there's two methods. The first is just to do equation 2 minus of equation 1 in the hopes of kinda joining the logs together. The other method is trying to get rid of the logs by converting them into index form and then isolating out I over c as the subject of formula to sub equation 3 into equation 4. So let's stick to the first method since it's a little bit easier. So with this equation over here, we can combine the logs together, and inside here it will become a divide. Now we just change it to a times by flipping the fraction, and you can kinda see that I and c values will actually cancel each other off, and we can get the value of s to be log 50 plus 2.4, which works out to be 4.1. Also, here's the other method, which is perfectly valid as well. You know what's really weird about this question? Them asking you to show that the x-coordinate of this point D satisfies some equation instead of just solving it. Now, this actually gives us a clue that we need to construct two simultaneous equations and then solve it from there. Because point D is the intersection of this line AD and this line BD, let's try to find the equations of these two lines first. To find BD, let's calculate the gradient using these 2 points, which works out to be -half. Now we sub in one of the points, so let's say 5, 6 over here, to get our C value of 17/2, and we have our first equation. The next equation is a little bit more tricky, but they gave us the information that the perimeter of this is 46, and since it's a parallelogram, these lengths here are the same. So using the distance formula, we can calculate the length of AB to be 13 units, and since two of these sides give us 46, we can get AD to be 10 units. Then we can let this point D be x, y, and since this length here is 10 units, we can use the distance formula to come up with our second equation. Now we just simply square both sides to make it easier and call this equation 2. Since we want to find the x-coordinate, we sub equation 1 into equation 2 to sort of get rid of the y, and after some expansion, we manage to show that it satisfies this equation over here. For this circles question, they kind of give you everything in terms of A, and then they ask you to explain why the y-axis is a tangent. Now the first step is to always try finding the center and the radius, so comparing it to the standard form, the center is -2a, a, and the radius is 2a. Now let's try sketching the circle on the graph, and the center is here, and since the radius is 2a, it actually touches the y-axis at only one point, which makes the y-axis a tangent. Now for the next part, we are looking for a line that's parallel to the x-axis and also tangent to the circle, where it only touches the circle at one point. So the only places that this line can be is here and here. Now we want to find the coordinates of these 2 points over here, and since the radius is 2a, we can kind of just shift the y-coordinate up and down by 2a, and we can get the y-coordinate of 3a and -a, and then we have these 2 points over here. This question has to get the award for the most confusing question in the entire TYS, because first looking at it, I was like, what topic even is this? We kind of know that we gotta manipulate this equation over here in order to sub it into the other equation by making e to the power of x over 2 the subject of the formula. So we can bring down this 2 from up here, and then we divide both sides by 2. Now since ln is log base e, let's change it to the index form, and we can finally get e to the power of x over 2 as the subject of formula. Now the last step is to just sub the value of e to the power of x over 2 into our other equation, and then we can just expand out the equation and then simplify it until we can get the final answer of y is equals to 2x plus 11. Ah yes, now these are my favorite type of questions. Short, straight to the point, yet challenging. So let's take a look at the tangent 2a formula and ask ourselves, what value do we have to let a to be? If we let a is equals to 7.5, on the left side we have tangent 15, but there's no way we can find the value of tangent 7.5 on the right side. So instead, let's try a is equals to 15, and on the left side we have tangent 30, which is a principal value, which is just 1 over root 3, and on the right side we have tangent 15. Now after we cross multiply and shift everything to one side, we can let u is equals to tangent 15, and ta-da! We have a quadratic. But we're not out of the woods yet. Since this quadratic can't be factorized normally, we have to use the quadratic formula! And after some simplification, we can get tangent 15 to be 2 minus 2 root 3 or -2 minus 2 root 3, but we kind of have to reject this value since tangent 15 is on the first quadrant and therefore it must be positive. This is an incredibly tricky question, and this time they give you 2 maximum points that lie on this cosine graph, and sketching it out, it'll look something like this. Now the first step is to calculate the period, which is here, and it's pi. So using the formula, which is 2 pi over b equals to the period, which is pi, we can calculate that b is equals to 2. Now comes the tricky part. Since the value of c is equals to 0, the amplitude of the Trigo graph is either positive 10 if it looks like a normal cosine graph, like this, or negative 10 if it goes the other way around like this. Now, if we trace the graph backwards period after period, going back to the origin, it looks something like this. If we focus on the right side of the graph, we can see that it's the second case, so the value of a is negative 10. Now for this kinematics question, it's asking for the conditions of C where the particle moves in a straight line and never turns around. So we know that V always has to be positive, so V is greater than or equals to 0. Now even though we don't know this C value, let's quickly sketch out the Trigo graph, which is a sine curve, and it looks something like this. Now because C is the amount that we have to shift the graph up by, we want to shift it such that the whole thing is above the x-axis. So the minimum amount that we have to shift it up by is 5 for it to be always positive. So the minimum value of C is 5. Okay, this R-Formula question is super interesting, but first let's just quickly find the value of R by doing square root of 7 square plus 4 square, and then we can calculate the alpha value by doing tangent inverse 4 over 7, which works out to be 0.52 radians. Now let's write out the R-Formula in our second equation over here, and the question wants us to find the maximum and the minimum value of this whole thing over here. Before that, we have to realize that for cosine of anything, the maximum and the minimum values are 1 and negative 1 respectively. In order to get the minimum, we kinda want this to be the biggest, so that 80 can minus off like a big amount. So we let cosine theta minus 0.52 is equals to 1, and then the minimum value works out to be 15. To find the corresponding value of theta, we can just solve for this equation over here, and it works out to be 0.52 radians. Okay, now for the maximum value of this thing, we want to minus off as little as possible this time. But here's the problem. If we set this to negative 1, it doesn't really make a difference since the whole thing is squared. So instead, let's try to set cosine theta minus 0.52 equals to 0, because that will totally cancel out this square root of 65 term over here, and we can get the maximum value of 80. Then for the corresponding theta value, we can just solve this equation over here, and then we can get the final answer of 2.09 radians. Another question from 2020 paper 2. I really feel sorry for the students who sat for this year. Okay, for the first part, we need to differentiate this using the product rule, and remember that we gotta bring the power down, power minus 1, and multiply by the differentiated thingy on the inside. Once we get something like this, the goal is kinda to factorize this 3x minus 5 terms together, so let's split this into 3x minus 5 to the power of 2 over 3 and to the power of 1, and then we can just factorize 3x minus 5 to the power of 2 over 3 here, and we just managed to prove the result. For the next part, let's write out the reverse equation like this, and notice that what we want is x times 3x minus 5 to the power of 2/3. But right now there's this 8x minus 5 that's blocking it, so we gotta expand this out over here, and after some expansion, we can finally see that we can get kind of what we want. So let's shift everything that we don't want onto the other side, and we can finally evaluate this integral over here, which just works out to be 3x minus 5 to the power of 5 over 3. And then we just factorize this out and divide both sides by 8, and then we can get the k value to be 1 over 8. The last part I think is the trickiest part, where they ask you to work out this definite integral by integrating it from 5 over 3 to negative 1. And putting these values in the integral, we can get the value of 0. Now you may be wondering, how can the area under the curve be 0? Since we know that it's not a horizontal straight line, it's a special case where the area above the x-axis, which is this region here, is the same as the area below the x-axis over here, and they sorta like cancel each other out to be 0. Okay, at this point, 2020 paper 2 has gotta be like the most difficult O-level paper of all time. This story here talks about a cone where water is poured in, and they ask you to find the volume of the water in terms of x. Now let's draw out the two similar triangles over here, and our goal is to find the radius of the small cone over here. So, using the similar triangles formula, we can get 3 over 5x as the radius. Now we just use the volume of the big cone minus the volume of the small cone and ta-da! We are done. Not bad so far. For the next part, we gotta construct the rate of change equation, so let's try to construct the first draft by putting dt over here and dx over here, and then we fill in our final variable dv. Now we notice that dt over dv is invalid since we only have dv over dt. So this term here should be on the other side instead. So let's try out dv over dx is equals to dv over dt times dt over dx, and every term checks out. We can then differentiate v in terms of x in order to get dv over dx is equals to negative 9 pi x squared over 25. Finally, we can just sub in all the values into the chain rule, and we can get the final answer of dt over dx is equals to negative 9 pi over 25k. The final part is the most difficult one, where they ask you to find t as a function of x. And since we have dt over dx, let's integrate this function with respect to x to get the equation of t. Since all this is a constant term, we just kind of add on the x over here, and we gotta find our plus c unknown constant here. We know that initially at t is equals to 0, the container is empty, so the x value is equals to 25. And subbing it in, we can get the c value of 9 pi over k. Okay, now let's try to solve for the value of k. So when t is equals to 72 pi, the height is 12, which is 25 minus x, so x is equals to 13. Now putting these two values inside, we can finally solve for the value of k to be 3 over 50 over here. Okay, this question holds a special place in my heart because this actually came out when I, Axie the Axolotl, took my O-levels, and it gave me PTSD for life every time I see this topic. Long story short, I basically spent 40 minutes on this question in the actual O-levels, and I don't think I got any of these parts correct, so I literally took a massive L on this one. The first part asks to find a relationship between this angle DEF here and this angle ABC here. And you can kind of see the tangent chord theorem. So angle ABC is equal to angle CAE. Since these two lines are tangents to the circle, angle CAE is equal to angle ACE by tangents from external points. Then if we take a look at this straight line and this triangle over here, angle DEF is equal to angle ACE plus angle CAE by the exterior angles property of a triangle, which is 2 times of angle ABC. Okay, now this part where they ask you to make an inference about the angle DFE requires some crazy visualization skill. So looking at this smaller triangle here, if we use the same method as before and apply it over here, we can kind of work backwards and use the tangent chord theorem to see that this and this are the same. Hence, angle DFE is 2 times of angle ACB. The last part goes pretty crazy as well, where they want you to prove whatever this is, but let's try to find a representation of angle EDF first, which is 180 minus angle DFE and angle DEF, which we worked on in the previous parts. So putting the values inside, we can get this expression over here. Okay, do you notice something about angles ACB and angle ABC combined? It's actually 180 minus angle BAC since they're all in the same triangle. So after some simplifying, we can get to prove this result over here. Welcome to the 2021 O-Level Final Boss, my favorite question out of the entire TYS because of how creative it is. It is a 12-mark, one-liner question that tests you on 4 different topics. The first step is to find the point M, and because it's a maximum point, we have to differentiate y to get dy dx and equate it to 0. So we just differentiate this to get 2 cosine x over 2 minus 1. After equating it to 0, we have to solve this trigonometric equation, and we get the basic angle of alpha to be pi over 3. Then we know that x over 2 is equals to pi over 3 since the range is only from 0 to pi, and any other value will be out of this range. Then we can get the x value of the maximum point M to be 2 pi over 3. Then the next step is to sub in this value into the equation of the curve, and we can get the corresponding y value of 2 root 3 minus 2 pi over 3. To calculate the area of the shaded region, we integrate the equation of the curve from 0 to 2 pi over 3, then we minus off this area of this triangle over here, by using half times base times height. So after doing the integration, let's start to put in the limits, and we gotta be careful to leave everything in terms of cert and pi, since the question wants us to prove this over here. So after some simplification, this 2 pi squared over 9 terms here cancel each other out, and we managed to prove that the shaded area of 4 minus 2 pi root 3 over 3 units squared. And that is it! The entire TYS gauntlet. If you're looking to try out more challenging questions, Paradigm Math has kindly let me share their O-level mock paper along with answers for you to try. It's really quite challenging, and it's probably on par with the 2020 A Math paper too, which sadly I can't show you the full paper because of copyright. So I encourage all of you to head down to your local popular bookstore and purchase your own copy of the TYS, and I wish you all the best for A Math O-levels this year. Take care, and Axolotl out!